Hello, and welcome to Perspectives, the podcast series from Luxoft, where we discuss the latest technology trends with IT experts and consider their impact on business and consumer lives. My name's Alison Keep. I'm the Global Marketing Director at Luxoft, and I'll be your host. I'm here today with Sam Mantle, who leads our Healthcare and Life Sciences practice, and Rich Pilling, Director of the Digital practice. In our last podcast, we focused on how technology is transforming operations, and today I'd like to talk about how advanced technologies borrowed from other industry sectors is helping to transform the workforce environment. Rich, why don't you start again?
Thanks, Alison. Standing on the shoulders of giants is always the way that you drive innovation. You use the tools of yesterday to build the tools of tomorrow, and so we can gain this increased pace of innovation all the time through this. One of the areas that is really important is being able to take innovations from one industry and use them in another. Up until recently, this has been a very difficult, if impossible, thing to do due to the specialised nature of the industries. However, the new digital transformation tools that we have nowadays allow us to do this and enable this cross-pollination of ideas and thoughts and hence speed of innovation. One area we have been looking at, especially recently, is around computer vision. We've been using this in the automotive industry quite a lot. Autonomous cars are a thing that's, if not here right now, but arriving very soon en masse. And the computer vision systems that use to effectively drive, no pun intended those, are very important. But it's interesting also when you can take that technology and systems and apply them to another industry, such as healthcare. Sam, can you tell us how we're using this in healthcare now?
Yes, so it's a really interesting translation between the different industries that, as a car is driving along the road, it's interpreting and learning about its surroundings using the computer vision and the artificial intelligence algorithms that sit underneath that. We're working on concepts where we take that technology and bring it into the scientific lab. So today, labs are on the whole very manual, very siloed, very human intensive in terms of the type of work that's done in there. And scientists, highly qualified research scientists, spend a lot of their time doing activities that could otherwise be done by machines. And in this instance, computer vision and the artificial intelligence that sits behind it is a great example of that. So we've taken rudimentary experiments where solutions are dissolving within tablets are dissolving within a solution, where readings have to be taken periodically to determine progress and speed and whether the experiment is actually being carried out in the way that we would expect, which today is all done in a very, very manual way. So we're able to use computer vision to replace the eyes and ears of the scientist, and then the artificial intelligence to build the algorithms to learn the patterns and the behavior, such that the scientist can focus on the value add activities and also be triggered by the computer vision and by the technical solution to intervene or take proactive steps prior to an incident rather than after the fact. So there's a huge productivity gain, and it's a great way that we're actually seeing how that technology from the automotive industry is actually extremely relevant within a scientific research setting.
And I guess the benefit of that is that scientists who would have normally been spending hours doing the manual experiments can spend their time on things which are more valuable to the business, that can spend their time focusing on other projects.
Other value add activities, and there's translations of that between other industries as well, where we're replacing manual activities with automation. Now, there's a productivity gain, so there should be a cost saving, but it also means that those scientists can be doing tasks that they wouldn't ordinarily have the time or the benefit to do. And for me, the big insight here is that it enables them to be much more proactive rather than reactive. Today, we wait for experiments to fail before we take corrective action. With computer vision AI, that problems are going to happen. The technology can identify problems before they occur. So there's a productivity gain and there's a time saving within that as well. And some of these experiments are not are not taking hours; they're taking weeks or even months. So the sooner you know that you need to take corrective action or do something different, there's a big value add in that whole experience.
Yeah, and it's the productivity gains are very interesting. When I started in my IT career many years ago, I'm feeling slightly old now. One of the first things I started to do was to automate all of the systems that I was looking after, because it was a lot easier. It meant I could be more productive. I could do much more interesting work as well. And then applying those techniques and technologies to lines of business, to industries, allowing these scientists to do the work which actually interests them intellectually, and the work that they are trained and highly educated for, is a really valuable thing. It allows it to take away the drudgery work, effectively, if you can call it that, and do the work which is the interesting part, which is also where innovation and new technologies and new medicines will come from.
Absolutely. And we're already looking at taking this concept and extrapolating it further, so that there's no reason why you couldn't have camera technology monitoring, rather instead of just one experiment, monitoring the movement and the utilization of equipment and instrumentation across the whole lab. So decisions could be taken about utilization or replacement, or even going into the predictive maintenance world as well, because in that type of setting, visual recognition of activities is something that is acceptable, and you can derive a lot of insight from.
And the equipment itself must be incredibly expensive as well. So from a maintenance perspective also, I'm thinking, if we can use these technologies, there's a benefit there too.
If you think about, if you want to trace and track the maintenance of a piece of equipment, a very complicated piece of equipment, for example, in the medical industries, having a ledger of all of its maintenance history and potentially ownership history and where it was made and where the parts came from, and having all of that in one place, that's a really good example of using a blockchain technology to be able to monitor and look at that properly.
Excellent. So what I'm now interested to talk about is how technology is impacting the customer or the patient. So let's talk about the patient experience in our next podcast. Thanks, guys.
Thanks, Alison.
Thank you, Alison.
You can listen to all our podcasts and find out more about our healthcare and life sciences practices on luxoft.com.